Okay, today we're at Newport Beach, California at Basin Marine, and we're going to be pulling out a hard bottom dinghy that we put the molecular coating on 2 months ago. And we're going to look at, for comparison and performance purposes, typically if we use the standard marine coating, after 2 months we'd see anywhere from 1 to 2 to 3 inches of growth of grass. And today, when we pull this boat, we're hoping to see very little staining and virtually no growth. I'm going to take the standard issue white Scotch-Brite pad that a diver would normally clean the boat with. And if you could come down a little bit. Just wipes right off. Just paper towel. Very, very little effort. Like a brand new boat. Obviously, the growth is minuscule compared to what you would normally see. Traditional bottom paint is a paint, and it works based on adhesive materials that are in the paint, so it sticks to the surface. And in order for it to fight off the marine growth, it typically will have a heavy metal like copper, or including pesticides, which are poisons. And now we're putting heavy metal and poisons in our water, which obviously is not a good way to go. A molecular coating is not a paint. It's actually a coating where on a covalent and an ionic level, which means covalently we cross-link with the hydrogen and oxygen atoms of the surface. And on the ionic level, we bond by the electrons of the surface with ours. So in two arenas, we're able to attach and adhere to the bottom of a vessel or any material on a covalent and ionic bond, which is way stronger than an adhesive coating. So we actually become the new surface. So it doesn't want to peel or flake off because it is the new surface. The other advantage is, if you look at a traditional paint, any kind of paint, varnish, polyurethane, if you look under a micron microscope in it, you're going to see holes in it the size of beach balls. And those holes become anchoring spots for seaweed and barnacles and mussels and all that type of growth that you get in the water. If you look at ours under a micron microscope, you may see the size of a pinhead. So it virtually eliminates any place for anything to anchor to and become part of that bottom. So the two main differences is ours isn't a paint. It's a molecular coating. Ours works on a covalent and ionic adhesion property, cross-linking with the hydrogen and oxygen atoms of the surface. And paints work with a mastic ingredient inside the paint like a glue. And those are the two fundamental reasons that they're completely different. I compare the traditional paints to the abacus and this to the scientific calculator. It's the next generation of coatings that we're going to see across the board in virtually every type of substrate that we see, not only boats, but everything else. So the technology of the past has gotten to where, as far as it can go, and now we're going into the next generation.